Descriptive statistics. Today I am going to discuss about bivariate data analysis. What do you mean by a bivariate data? Bivariate data is nothing but the data that needs to be two variables, and mainly it is used for studying the relationship between the variables under study. How the bivariate data is analyzed? Firstly, we can draw the scatter plot, that is taking one of the variable on x-axis and another variable in y-axis. We will plot the points to identify whether there is a relationship between these two variables in the study. And next, the correlation analysis. It defines how much relationship or how strength of the relationship can be studied using correlation analysis. And in regression analysis, we can study the nature of relationship, or it can be used to predict one of the variable with the help of the known value of the other variable. We are going to discuss in detail about regression analysis. And what do you mean by the word regression? Regression means stepping back or returning to the average value. Regression studies the nature of relationship between the variables and it is a mathematical measure of average relationship between two or more variables in terms of the original units of data. Then, if the regression analysis is used to study about the two variables at a time, it is called single regression, whereas if we are using more than two variables at a time, it is called multiple regression. And in regression analysis, two types of variables are involved: dependent variable and the independent variable. The variable whose value is influenced or to be predicted is called the dependent variable, whereas the variable which is used to predict the value of the other variable is called the independent variable. Now, linear regression and non-linear regression. Considering bivariate data, the data is plotted on a graph to obtain the scatter diagram, and the points in the scatter diagram will more or less concentrate on the curve, and it is called a curve of regression. If the curve is a straight line, then we say that it is a linear regression or linear relationship between the two variables in the study. If it is not like that, we will say it is a non-linear relationship. Lines of regression. In the lines of regression is a line which gives the best estimate of one variable for any given value of the other variable. Then the lines of regression are obtained using the principles of least squares. Two lines of regression: lines of regression of y on x as well as lines of regression of x on y. If line of regression of y on x gives the best estimate about the value of y for specified value of x, whereas the lines of regression of x gives the best estimate of x for any specified value of y. Now, how to derive the lines of regression of y on x as well as x on y? For that, we have to consider n pair of observations on two variables x and y. Let the observation be x1, y1, x2, y2, etc. x and y. Let the regression line of y on x be y is equal to a plus b, where a and b are constant. And we need to estimate these two constants first. For that, let us consider the scatter plot. In the scatter plot, like pi, the coordinate of pi is xi, yi, which is in a general form of the scatter plot. Now, we have to draw a perpendicular from pi to the x-axis to meet at n, and the perpendicular pi m is cutting the y equal to a plus bx line at the point h, and the coordinate of h is xi, a plus b xi. The error of estimate of pi is given by pi hi, which is equal to pi n minus hin, which is yi minus a minus b xi. According to the principle of least square, we have to determine the constants a and b in equation 1 such that sum of squares of errors is minimum. That is, E is equal to summation I from 1 to n yi minus a minus b xi the whole square should be minimized. In order to minimize the above function, based on the rules on differential calculus, by using the principle of maxima and minima, we can take the partial derivative of E with respect to a and b and equate it to 0. First, we have to take the partial derivative of E with respect to a, and on equating it to 0, and on simplification, we get the first normal equation to be summation a equals na plus b summation xi. And again, we have to take the partial derivative of E with respect to b, and on equating it to 0, we will get the second normal equation, which is summation yi xi equals a summation xi plus b summation xi. Now, to obtain the regression line, we have to consider the normal equations as respectively 1 and 2. First, we have to divide 1 by n summation yi is y bar and 1 by n summation xi is x bar. So the equation 1 will reduce to y bar equals a plus bx bar. Now it is obvious that the regression line of y on x passes through the point x bar y bar. Now, in order to derive the regression line, we have to consider the covariance and variances. So first we take covariance between x and y, which is nothing but 1 by n summation xi minus x bar into y minus y bar. On expanding using distributive law and on simplification, we will get the form as 1 by n summation xi yi minus x bar y bar. From this, we have to take 1 by n summation xi yi to one side and it will become covariance between xy plus x bar y bar. Now consider the variance of x, which is sigma x square equals 1 by n summation xi minus x bar the whole square. On expanding using a minus b the whole square and on simplification, we will get the equation of sigma x square to be 1 by n summation xi square minus x bar square. And from this, we have to take that 1 by n summation xi square as sigma x square plus x bar square. And we have to call that equation 3 and equation 4 respectively. Now we have to take the second normal equation. We have to divide the second normal equation by n so that the equation reduces to 1 by n summation yi xi equals a into 1 by n summation xi plus b into 1 by n summation xi square. Now we have to use the result in 3 which is in terms of covariance and in 4 which is in terms of variance of x in the obtained equation, and it will reduce us to covariance between xy plus x bar y bar equals a x bar plus b x square plus x bar square. Now we have to multiply our y bar equals a plus bx bar with x bar, and we will get it as y bar x bar equals ax bar plus bx bar square. So in equation 5 on the RHS, ax bar plus bx bar square can be replaced with y bar x bar. So that our expression in 5 becomes covariance between xy plus x bar y bar equals x bar y bar plus b sigma x square. X bar y bar or other side of the equations get cancelled and it produces the covariance between xy equals b sigma x square. From this, we can obtain the value of b as covariance between xy by sigma x square. Now, as we have considered the general form of the equation y equals a plus bx and b is the coefficient of x, which is nothing but the slope of the regression equation of y on x. Further, we have already seen that the regression equation of y on x passes through the point x bar y bar. So using slope point of equation of a line, the regression line of y on x can be obtained as y minus y bar equals slope of b into x minus x bar. So we have to use the substitution for b as covariance between xy by sigma x square to obtain equation 7. Now we can change the covariance between xy in terms of correlation coefficient. So that we know that the correlation coefficient R is covariance between xy by sigma x into sigma y. From this, on cross multiplying, we will get the covariance between xy as R into sigma x into sigma y, where sigma x and sigma y are nothing but the standard deviation of x and y respectively. Therefore, equation 6 can be written as y minus y bar equals R sigma x sigma y by square into x minus x bar. Sigma x in the numerator and one of the sigma x in the denominator can get cancelled, and the equation of the equation of y on x will become y minus y bar equals R sigma y by sigma x into x minus x bar. Similarly, regression equation of x on y is x minus x bar equals R into sigma x by sigma y into y minus y bar. Now, in regression equation of y on x, the term in the RHS that is multiplied with x minus x bar, which is R into sigma y by sigma x, is the regression coefficient of y on x and denoted by Bivariate. Similarly, in the regression coefficient of x on y will be bxy and is R sigma x then sigma y. Thus, the lines of regression can also be written as y minus y bar equals byx into x minus x bar, and the regression line of x on y is x minus x bar equals bxy into y minus y bar. Also, we can find the relationship between the correlation and regression coefficient. The correlation coefficient R is the district mean of regression coefficient bxy and byx. That is R is equal to square root of bxy into byx.